Property is if each element of a row or a column of a determinant consists of two terms each, then the determinant can be expressed as the sum of two determinants. To explain this, let D equal to A1 plus X1, B1 plus Y1, C1 plus Z1 as the first row, A2, B2, C2 as the second row, A3, B3, C3 as the third row. Expanding this, we get A1 plus X1 times B2, C3 minus B3, C2 minus B1 plus Y1 times A2, C3 minus A3, C2 plus C1 plus Z1 times A2, B3 minus A3, B2. Taking terms containing A1, B1 and C1 separately and X1, Y1, Z1 separately, we get A1 times B2, C3 minus B3, C2 minus B1 times A2, C3 minus A3, C2 plus C1 times A2, B3 minus A3, B2 plus X1 times B2, C3 minus B3, C2 minus Y1 times A2, B3 minus A3, C2 plus Z1 times A2, B3 minus A3, B2. The first three terms make the determinant A1, B1, C1, first row, A2, B2, C2 as the second row, A3, B3, C3 as the third row. The last three terms make the determinant X1, Y1, Z1, A2, B2, C2 as the second row, A3, B3, C3 as the third row. Thus, the given determinant has been expressed as the sum of two determinants. Now we have the following observations here. Note that, number one, it should be noted that the row or column which consists of two terms each gets split into two determinants, but the other two parallel lines remain common to both two determinants. Second, if there are m terms in one column and n terms in another column, the determinant can be split into m into n determinants. Third and important observation is, conversely, if there are two determinants having two rows identical, we can combine them into a single determinant, wherein two rows will remain the same, while the elements of the third row getting added. For example, the determinant consisting of x, y, z in the first row, A2, B2, C2 in the second row, A3, B3, C3 in the third row, plus P, Q, R in the first row, A2, B2, C2 in the second row, A3, B3, C3 in the third row, gets equal to x plus P, y plus Q, z plus R. A2, B2, C2, second row, A3, B3, C3 in the third row. To understand this, see this property in the reverse way. This can be generalized to any number of determinants.